Hello all, we are starting our next video here on the Python 101 series. So this is video number 2. Here I am going to cover the program number 3 and if possible program number 4. Along with that I will also do a workout of one aptitude question as well. So this is the plan for this particular lecture in our Python 101 series. So let's start the video right now. So this is program number 3. So to be able to write our code, I will create another cell. So I choose this particular cell with markdown and type this as factorial of a number. This is our program title. So I am going to follow a method of programming called recursion in this program. So recursion is a concept in programming. It's equivalent or it's alternative to another concept called iterative programming. Recursion is a very simplified way of doing programming, wherein a function calls itself. This is recursion. A function calling itself is called recursion. So every time a function calls itself, the function is called for a smaller set of inputs. So I will now write the code and then we'll explain further with respect to recursion. So let's write our program here. So to write our program, I write this as a function. So I create a function for that. The name of the function I call it as factorial, and this takes an input n, and it's a function, so it's a block statement. So I end from start line of the function with colon, so it automatically insert the next line with 4 spaces of indentation, as you can see here. So recursion has 2 parts to it. Any recursion function has 2 parts to it. So this is factorial function. So factorial of a number that is 0, if it is factorial of a number 0, then the value returned is 1. Else the function calls itself. Okay. So how it calls? N star factorial of n minus 1. So that's all our program is. Okay. So let me call this function with some sample input. For that I am going to ask for a user input. Let's say num is a variable where I am asking for user input. So input is sought from the user using a function called input, as we know from last class. So enter a number. So when this particular function asks for a user input, and for this function I am going to call factorial function. So I am going to print this out. So I am writing this function. I'll shortly explain line by line how the function is written and how it is called. So it is asking for a user input. Let's say I am typing it as 4. Okay. So factorial of a number of the number 4 is 24. Right. Factorial of 4 is 4 factorial is equal to 4 into 3 into 2 into 1. So you can say it is 24. Similarly, if I type the user input as 5, you will get the output as 120. So factorial of 5 is equal to 5 into 4 into 3 into 2 into 1. So what you get is 5 into 4 20, 60, 120. So that's our answer. So you can call this for any number. Let me explain the function now. In addition to that, I will also explain the concept of factorial recursion as well. So this function, as you can see, calculates the factorial of a number that the user is inputting. So first, this program starts from here. User inputs a number using and that is enabled using the input function. As you know, input function returns a string data as a return value, and that string return value is stored here. Factorial of a number, factorial is calculated for a number. It cannot be calculated for a string. So whatever the number that was entered by the user is stored in a num variable as a string. So this has to be converted into integer, and that's what we are doing here. And the converted number, that is the integer number, is now passed to the function factorial. So the control now shifts over to this place. The value here is 4. Let's say I am entering 5 here. The value here is 5. So n is equal to 5. Okay. First is n is equal to 5. It checks, next line is, it checks if n is equal to 0. Obviously, this condition is not satisfied because our n value is 5 now. So if n is equal to 0, that function is not satisfied. So the control returns to the else class or else part. At this time, it is calling a particular expression. It is returning a particular expression. So as you can see, this expression is calling factorial again. So this is the recursion that I am talking about. The function factorial calls the same function, that is calls itself, but with a smaller input. Instead of n, it is calling with input n minus 1. Now, so in this case, it is 4 into factorial of 4 minus 1, that is n minus 1 is 5 minus 1, that is 4. Now again it goes to the same function. Now currently the n value is 4. Okay, n value is 4. So it is checked here if n is equal to 0. It is not 0. So else is called. So now the function is called for a smaller input, that is 4 minus 1. So it becomes n star factorial of, okay, so here it is 5 star factorial of 4, because n star factorial of n minus 1, initially n is equal to 5. So it is 5 into factorial of n minus 1, n is 5. So 5 into factorial of n minus 1, which is 4. So the factorial is called with value 4. It is checked if n is equal to 0. It is not 0. So the control moves to the else block. So now the function is called with n is equal to 3. Okay. So it is 4 into factorial of, right now the value of n is equal to 4. So n minus 1 is equal to 3. So it becomes 3. Now the value 3 is passed to the function. same function is called again. So factorial of 3 is called. So the expression now becomes 5 into 4 into factorial of 3, right? So 3, n is equal to 0. So but n is equal to 1, 3 in our case. So n is equal to 0 condition is not satisfied. So the control moves to the else block. So what is now evaluated is 3 into factorial of 3 minus 1, that is 2. Now factorial of 2 is called. Again checked if n is equal to 0. It is not 0. So control goes here. Now the expression becomes 5 into 4 into 3 into. Now the n value is 2. So n into factorial of n minus 1 becomes 2 into factorial of 2 minus 1 is 1. Okay. Now at this time the factorial function is called again with n is equal to value 1. Again it is checked if n is 0. It is not 0. So the else block is called. So the expression now becomes 5 cross 4 into 3 into 2 into factorial of 1 is equal to 1 star factorial of n minus 1, that is 1 minus 1, 0. So now again recursive call. Factorial is called again but with an input 0 this time. So if n is 0, that condition is becoming true now. So the value of 1 is returned here. Okay. So the expression now becomes 5 star 4 star 3 star 2 star 1 star factorial of 0 is 1. Okay. So this is our value, which is 20, 60, 120. That is the value that is finally returned to the calling function, and that is the output that is printed here. So if you see, this is an example, a very good starting example for a type of function called recursion. In this recursive function, there are two parts. One is the base case. This is base case. Okay. And this one is recursive case. Okay. So two parts to it. One is called a base case. The other is recursive case. Okay. Let me explain these two now. So the base case is required. Base case specify a condition which when satisfied the program will be terminated. We will exit from the program successfully. Right. So the moment the input becomes 0, value 1 is returned and the program is completed. Okay. So this is the base case, and base case is required to successfully exit the program. Without this base case, the program will go in an infinite loop. It will run forever. The other part is recursive case. So this is where the function is called by itself again and again and again, with one catch, that every time the same function is called, it is called for a smaller input. That's the point you should understand. First time it is called with input n. Next time it is called with input n minus 1 in this particular example. Next time it will be called with input n minus 2, n minus 3 and so on. And it is called until it becomes 0. The moment it becomes 0, value 1 is returned, and all the expressions that have been arrived at so far will be calculated and the final value will be returned. So this is how a recursive call or recursive function will work. And Fibonacci series calculating the factorial of a number is a classic example to start understanding this excellent concept of programming. So typically a recursive function is worked out using a data structure called stack. So as I'm not sure whether many of you would have been familiar with the stack data structure. I have not chosen to trace this program using stack. Instead, I have traced the program in a much simpler way using by recursively building expressions like this. So I started with 5, then 5 into factorial 4, then 5 into 4 into factorial 3, and so on, until I nailed down to all the known values which evaluated in this particular case to 120. So similar way you can pass another number, let's say 8, n as 8 or number as 8, and then trace this particular program. Okay, so I hope you are able to understand this program. Now let's move on to our next program for the lecture today. So the next program for the lecture today is Fibonacci sequence. This is our next program. Fibonacci sequence is formed like this. The first number is 0. The second number is 1. Okay. Third number is formed by summing the previous two numbers. In this case, the previous two numbers are 1 and 0. So the third number is 1. Fourth number is formed by summing the third and second number. That is 1 plus 1. The fourth number is 2. Fifth number is formed by summing 2 and 1. That is the previous two numbers. The fifth number is 3. The next we are forming the sixth number, which is formed by summing fourth and fifth numbers. So this number becomes 5. And next number is 8. The next number is 13 and 21 and so on. This is a Fibonacci sequence. Okay. So as you can see here, the same operation happens over and over. First two numbers are fixed, but after that these two, the next number is formed by the sum of the previous two numbers, and this logic is applied for the formation of all the other subsequent numbers. So same operation is done again and again. So same function happens again and again with respect to each value in the sequence, which means this is a clear case for applying recursion. So we are going to now write this particular program using a recursive call. Okay, all right. So for that, let me create a cell and let me name this cell as Fibonacci sequence, and we are going to write this program for forming this Fibonacci sequence. Okay, so our function call goes like this. This is the function. So we are writing with the keyword def Fibonacci, and it is accepting the value as n. Okay, fine. So like I said earlier, in the case of recursion, there are two parts to recursive function. One is base case, the second is recursive case. Okay, so the base case is for the first two numbers, right? The value returned is the same value. Okay, so as you can see here, the value returned is same. Okay, so if n is less than or equal to 1, then return 1. Okay, that is our function. If n is equal to return n. Okay, If n is less than or equal to 1, return n. Okay, this is the base case. Else, we are now specifying the recursive case. Return, we are forming recursion. Okay, we are forming recursion using the last two numbers. So we are forming this as Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is what I am going to write. So this is my function, this is the base case, and this is the actual recursive case. So let me call this function for a particular value that the user enters. For that I am calling this function using input. So I am asking the user to enter a number, and this is, like I said, is returning a string. So I am calling Fibonacci of, so I will call this as, so enter a number of terms. Okay, so enter how many terms you want in the sequence, whether you want to have 5 terms or 6 terms or 7 terms. So let's say we need 5 terms. Okay, for that I am going to write a for loop for I in range of int of num. Okay, Fibonacci of I. So this is our function. So I am going to call this using the print function. Okay, so let me call this function. So it is giving some error for I in range of okay. So this is extra bracket we have. Okay, so let me enter say 5. So as you can see here, it has created the start number is 0, then 1. These two are specified by the base case, and then adding these two gives the number 1. Adding the second and third number gives the fourth number, which we get as 2. Adding the third and fourth number gives the number 3, which is our fifth number, and it goes on like this. What I want is, I want only 5 numbers to be printed. That is what I entered. So it has printed 5 numbers. Okay, so I can use an end argument so that the value is printed in just one line: 0 1 1 2 3 5. Let me give some space. So 6. So it is printing first 6 numbers of that Fibonacci sequence. So let's start tracing this program. So this is my function which actually calculates the Fibonacci sequence, and the function is called from here. It is called for a number of terms that the user specifies. So that I get as input from the user. So user enters how many terms he wants in the sequence. Let's say he enters 6. So now we run a for loop for that. A range of int of num. So this num becomes 6. Okay, that is string 6. So the for loop executes from 0 to range of 6. Okay, but range of 6 returns the number 0, 1, 2, 3, 4 and 5. Range of 7 will return 0, 1, 2 etc. up to 6. Range of 4 will return a series of numbers as 0, 1, 2, 3. So this is how the range function works. So in this case, I am asking that this program creates 6 terms in the Fibonacci sequence. Okay. So the range is called for values from 0 to 5. So first 0 is passed. The program executes for value 0. I is equal to 0. So I, for this value Fibonacci is called. Okay. So I is 0. So Fibonacci of 0 is called. So n becomes 0. Here n is less than or 1 condition is evaluated. That is base case is evaluated. And obviously it is 0. It is less than or equal to 1. So in this case the value returned is n, which is 0. So the first number returned is 0. Okay. Now for the second, now it is called for the for loop does not end there. Now it is executing for the next value of I, which is 1. So Fibonacci of 1 is called this time. Okay. It is passed to the function. N is 1. Okay. So the base condition is satisfied because n is equal to 1. So it returns n whose value is 1 right now. So next number in the sequence is 1. Now the Fibonacci of I is called for I value 2. For this value it is called. So n becomes 2 in this case. Base condition is evaluated. N is less than or equal to 1 is checked. But in this case n is equal to 2. So this condition becomes false. Therefore it moves to the recursive case. This is the recursive case. In the recursive case, what happens? The same function is called twice. Okay, that is the same function is called twice. That is factorial of the value that is passed to here is 2. So 2 minus 1, that is passed is 2 minus 1 is 1. Okay, plus factorial of 2 minus 2, that is 0. These two are called. Factorial of 1 is called and factorial of 0 is also called. Whatever value we get from these two are getting added up, that is plus. So now factorial of 1 is called. N becomes 1. The base case becomes true. So factorial of 1 becomes 1. Now factorial of 0 is called. N value becomes 0. Base case is satisfied. So n value is returned to the caller function, which is this one. N value now is 0. So the value of this is 1 plus 0, which is equal to 1. So the next number in the sequence is 1. Okay. Now function returns here. Previously we have called for I value of 2. Now the I becomes 3. For that value Fibonacci is called. So Fibonacci of 3 is called. So n becomes 3. The base case is not satisfied. So it moves to the recursive case. Okay. So in this, the factorial function is called 2 times. 1 for value of n minus 1. Right now the value of n that we have is 3. So it is called for n minus 1, that is 2. And again it is called with value n minus 2, which is 1. Okay. Now this is evaluated first. Factorial of 2 is called. So n becomes 2. Base case is not satisfied. So the control moves on to the recursive case. So the factorial of n minus 1 becomes, for this we get factorial of 2 minus 1. Factorial of 2 minus 1, that is 1, plus factorial of 2 minus 2, that is 0. So this is the expression we get. This is the expression we get for factorial of 2. We also have factorial of 1. Okay, already there. So let's write that down. So factorial of 1. Now factorial of 1 is called now. N value is 1. Base case is satisfied. So 1 is returned. Now the factorial of 0 is called. N is 0. Base case is satisfied because n value is less than or equal to 1. So 0 is returned. So it is plus 0. Now factorial of 1 is called now. The base case is satisfied. N value is 1. Base case is satisfied. So the value becomes 1. So the value becomes now 2. So this is the next number in the sequence. So we have executed the for loop for 0, I is equal to 0, I is equal to 1, I is equal to 2 and I is equal to 3. Next I takes the value 4, for which we are now going to execute the factorial function. So I is equal to 4 right now. Okay. So with that the factorial function is called. That is factorial of 4 is called. So n becomes 4. N is less than or equal to 1? No. So the base case is not satisfied. So it control moves on to the recursive case. Like I said earlier, in the recursive case the factorial function is called 2 times. So first it is called with factorial of n minus 1. Right now n value is 4. So it is called with n minus 1, that is 4 minus 1, so 3. And again it is called with value n minus 2, n is 4. So 4 minus 2, 2. Okay. Now factorial of 3 is evaluated. That is factorial function is called with value 3. base case is not true, so the control gets shifted to the recursive case. So factorial of n minus 1 is called, we are evaluating this part. So n is equal to 3, so n minus 1 is 2, and it is called with again factorial of n minus 2. So it is factorial of 3 minus 2 factorial of 1. Already we have factorial of 1, so that is retained here in this expression. Now this gets evaluated. Factorial is called with value I is equal to 2. So n becomes 2. Base case is not satisfied. So recursive case is called. So n value is 2 here because 2 is passed here. So it gets split up into 2 factorial calls. One is with factorial of n minus 1, that is 2 minus 1, 1, plus factorial of 2 minus 2, that is n minus 2, n is 2, so 2 minus 2, 0. And we also have 2 other values here, which are factorial of 1 plus factorial of 2, both of which we have to retain in the expression. Now factorial of 1 gets evaluated. It is called, so n becomes 1, base case is true, so value returned is n value is 1 in this case, so value returned is 1, so this becomes 1. In a similar way, factorial of 0 is called, the value returned is 0, value returned, the value input passed to the function is 0, so n is 0, base case is satisfied, so the value returned is, the same value is returned, so 0 is returned. So we have now evaluated this particular part. So in a similar way, factorial of 0 will be 0 and factorial of 1 becomes 1. Okay, now let's understand quickly factorial of 2. Factorial of 2 is called, value of 2 is passed for n, so base case is not satisfied, so recursive case is evaluated, so factorial is called twice, so we get factorial of n minus 1, that is 2 minus 1, 1, plus factorial of 2 minus 2, that is 0. So like we saw in the previous explanations, this becomes 1 plus 0 plus 0 plus 1. Factorial of 1 we have already seen, it is same number, that is 1. Factorial of 0, same number, 0. So if you add up all this, we get 3. So that is our next number. If you see here, 3 is the addition of previous 2 numbers, 1 plus 2, and we get 3. So factorial of 4 is 3. Okay, now the value of the factorial function will be called for the I value of 5. So factorial 5 is called, and in a similar way the whole expression sequence is constructed, and we will get, if you trace like this, you will get that it will be 5. Okay, so what we wanted was, the user wanted to print the first 6 numbers of this Fibonacci sequence, and that's what we have achieved here. So you can enter, and this is how this particular Fibonacci sequence using recursion works, and this is the program for that, and I just explained to you how the tracing of this program works. Okay, so you can trace this for some different values and have a better understanding of this particular program. So recursion is a great programming style and is used in several industrial applications as well, and it has a lot of use cases across the industries. So this is one concept that you may want to clearly understand. And these two programs that we saw today, namely the factorial, calculating the factorial of a number using a recursive function, and constructing the Fibonacci sequence using another recursive function, will give you a good start towards understanding recursion in programming. So those were the two programs we wanted to see today, and we will now move on to our aptitude question today. Okay, so we move on to this particular segment of today's video, which is aptitude. So today's aptitude question is this one: what is the sum of two consecutive odd numbers, the difference of whose squares is 56? Okay, that's the aptitude question today. Let me work this out here, so that you will be able to gain a good understanding of this. Okay. So if we read the question, what the question asks, that the problem that is asked is, we need to find out the sum of the two consecutive odd numbers. Okay. So let's consider that the first odd number is x. The second number is also odd number, and these two numbers are consecutive. Okay. So odd number, if one number is odd, then the next consecutive odd number is 1 plus 2, 3. Okay. The next consecutive odd number is 3 plus 2, 5. Okay, and it goes on like this. Similarly, if x is one odd number, the next odd number to x will be x plus 2. Okay, so we are asked to find the sum of x plus 2, given that the difference of the squares of these two numbers is 56. Okay, under this condition, what is the sum of these two consecutive odd numbers? That is what we are asked with. Okay, so it is given clearly that the difference of these two consecutive odd numbers is 56. So which means x plus 2 the whole square minus x square is 56. You cannot, this is our one odd number, this is another odd number. Obviously x plus 2 is a higher odd number and this is a lower odd number. You cannot reverse this expression, because squaring the bigger number and subtracting from it the square of the smaller odd number, then only you will get a positive number. If you reverse this, that is x minus x plus 2 the whole square, if you reverse this, you will not get a positive number. So that's why you have to be very careful in writing this particular equation. It is x plus 2 the whole square minus x square is equal to 56. It cannot be x square minus x plus 2 the whole square. This cannot be positive. So you cannot write the expression in a reverse way. So you have to be careful with this. And this is where most people may screw up this or make mistake in this particular problem. So now we have constructed this equation based on the constraint that is given. The constraint given is the difference of the squares of these two numbers is 56. So let's work this out. This is simple algebraic equation, right? So if you expand this, it is x square plus 4x plus 4 minus x square is equal to 56. So x square and minus x square gets struck. So 4x plus 4 is equal to 56. Okay. So x plus 4 is equal to 56 by 4. Okay. So which is, sorry, x plus 1 is 56 by 4. So x plus 1 is equal to 14. That implies x is equal to 13. So one of the smaller odd number is 13. So the bigger odd number obviously is x plus 2 so the bigger odd number is x plus 2, which is 15. Okay, we have been asked, we have been given that the two odd numbers are consecutive. Consecutive odd numbers have a difference of 2, so we have to add 2 to x to get the next consecutive or next odd number. So these two are our odd numbers. So we are asked to calculate their sum. Okay, so we have been asked to calculate their sum. So one odd number is 13, the second odd number is 15, the sum of them is 28. So this is our answer. So the answer to this question is 28. So with this we will end today's lecture. So we will meet again in the next lecture with another 1 or 2 programs under our series Python 101 and an aptitude question. So see you for now. Take care. Bye.